All right, guys, I'm going to go over how to do the 11 problems from the classwork from today. All right. Um, like I said, almost most of these have to do a chain rule. Only I think number 10 doesn't have to. All right. And remember, chain rule you use anytime that you have a quantity raised to a power or you have trig with something besides x after it. Okay. So here we have the quantity 5x plus 2 raised to the 6. So we're going to do the chain rule, all right, which is the derivative of the outside, keeping the inside the same, times the derivative of the inside. So for example like this, we move the 6 out to the front, right? So that's me taking the derivative, just the power rule. And then we take 1 away. So that is the derivative of the outside. We keep the inside the same. So we have 5x plus 2. And then we multiply by the derivative of the inside. The derivative of 5x plus 2 is 5, leaving me with just multiply 5 times 6, and I get 30 times the quantity 5x plus 2 to the 5th power. And there's my answer. All right. All right, number 2. All right, number 2 is also the chain rule. We have a trig function with something inside without just x. Remember, the derivative of sine x is cosine x, right? So when the chain rule says take the derivative of the outside function is sine. So we take the derivative of sine, which is cosine, but we don't write x after it because we keep the inside the same. Whatever was after sine stays after sine. That is keeping the inside the same, which is 2x plus 4. All right. And then so we took the derivative of the outside, we kept the inside the same. Now we need to multiply that by the derivative of the inside. The derivative of 2x plus 4 is 2. All right. If you left this as an answer in a quiz, I would be fine with it, but the 2 should go out in front. 2 times cosine of 2x plus 4 is our answer. All right. For number 3. All right. Number 3, we have a quantity raised to a power. It is a fraction. However, there's no x on top here. So this isn't the quotient rule. But what we have to do is just like if we had negative 1 over x to the 4th, previously, we had to rewrite that as negative x to the negative 4th, right? Before we did the power rule. So we're going to move this to the top and get negative the quantity 3x squared minus 1 to the negative 4th. All right, so we're now going to do very similar to what we did number 1. All right, this is a quantity raised to a power. You take the exponent, bring it out front, negative 4, but there's already a negative out there, which makes it a positive 4. Keep the inside, whatever's in the parentheses stays in there. We had negative 4. I subtract 1 from negative 4. I get negative 5. And then I multiply by the derivative of the inside. The derivative of 3x squared is 6x. The derivative of negative 1 is just 0. So we end up with that. So we get 6x times 4, which is 24x. And then we have to move anything with a negative exponent to the bottom. So it's 3x squared minus 1 to the 5th power. And there is our answer. All right. All right, next one. All right. So for number 4, all right, we have things being multiplied, and there's an x out here. This is not, you do not just do the chain rule where you put the 5 out in front, put 5x squared. There's an x out here. If there's just a 2, then you would. But this is the first function. This is the second function. So this is the product rule, which is the first times the derivative of the second plus the second times the derivative of the first. All right. So we just go and do each one, just take it as one, each separate step. The first one is x squared times the derivative of the second. All right, but to take the derivative of the second, you need the chain rule, just like we did up here in the top, number 1 and with number 4. You move the 5 to the front. You keep the inside the same. You take 1 away from the exponent. It was 5. It is now 4. And then you multiply by the derivative of the inside. The inside is 2x plus 1. The derivative of that is 2. All right. And then you do plus the second, which is 2x plus 1 to the 5th, times the derivative of the first. The first is x squared. The derivative of that is 2x. All right. If you get that, that's like, you know what you're doing. But just to simplify this first term, 2, 5, and x squared is 10x squared. times 2x plus 1 to the fourth, plus just move the 2x out front there. 2x because it's another term. 2x times 2x plus 1 to the fifth. And this is my answer. All right. All right, look at number 5. All right. You have to remember that this, when the exponent is in between the tangent when it comes after it, this means the quantity tangent of 6x squared. All right, so we have a quantity raised to a power. That means we have to use the chain rule. The 2 comes out in front. We keep the inside the same. You take 1 away from 2, which is 1. I'll write it there. You normally don't have to write that, but that's fine. Now you have to multiply by the derivative of the inside. Well, to get the derivative of tangent 6x, we treat that just like we did with number 2, right? It's the chain rule again. So we got to take the derivative now. Tangent is the outside function. 6x is the inside. The derivative of tangent is secant squared. So tangent is secant squared. You keep the inside the same, so we write 6x again, but now we have to multiply by the derivative of the inside. The inside is now 6x, so that is 6. All right, you write that, you're good. Just move the 6 to the front, so it's 6 times 2 is 12. Tangent of 6x, secant squared 6x. There's your answer. All right, 6. Another trig function, something after it's not x, so this is the chain rule. This is the outside, square root of x is the inside. All right, so the derivative of sine, once again, is cosine. You keep whatever's after it in there. Now, in order to take the derivative of the square root of x, square root of x is x to the 1/2. All right, so then you have to bring out the 1/2, and I get 1/2 x to the negative 1/2, which is 1 over 2x to the 1/2. All right. Or another way you could write this if you want is 1 over 2 root x. All right. It's a good idea to maybe memorize this derivative because we use it a lot. All right. You can leave that as your answer. I'm fine. We write cosine root x over 1 over 2x to the 1/2. All right. So number 7 is very similar to number 5. All right. Where you have to realize that this means cosecant of 3x to the 4th power. All right, so this is going to be another double chain. Whenever you have an example like this is always double chain rule. So we do the power rule, derivative the outside, keep the inside the same, cosecant 3x, the 4th becomes cubed. Now we take the derivative of the inside, which means we do the chain rule again. Now with cosecant as the outside, cosecant, derivative of that is negative cosecant, cotangent, but you keep whatever's after it has to stay there. And then don't forget to multiply by the derivative of the inside. The inside is 3x, which is 3. If you get this, perfect. All right. Now to make it perfect, I would put the 4 times 3, which is negative 12. And then you can write cosecant. I'm going to write it like this. But if you want to write it like we have here, that's also fine with a quantity cubed. That's great. Cosecant 3x, cotangent 3x. There we go. All right. Now with 8, all right, this is where you have the option of if you want to make this into a product rule instead of a quotient rule, you could make this 4x plus 1 to the negative 5th and bring it up here if you wanted to, and then do the product rule. All right. Right now, I'm just going to do the quotient rule. You can do the product rule, but let's do one to practice. Since we already did a product rule up here, let's do a quotient rule to practice that. Remember, it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. All right, so the bottom is 4x plus 1 to the 5th times the derivative of the top. The derivative of 7x squared is 14x minus the top, which is 7x squared, times the derivative of the bottom. In order to do the derivative of the bottom, you need to do the chain rule, right? Bring the 5 out front. And hopefully, the more practice you're doing with this, the better and easier it is becoming. Keep the inside the same. The 5 becomes a 4. Do not forget to multiply by the derivative of the inside. The inside is 4x plus 1. The derivative of that is 4. And that is all over the bottom squared. When I square something to the 5th power, it becomes to the 10th power. All right. Now, if you can get this, great. Probably for the first quiz we take on this, which coming up probably early next week, maybe Monday, this would be a good answer. All right. But just to make it a little bit better, all right, I'm going to put the 14x out front, and then the 4x plus 1 to the 5th. And then I got 7x squared, 5. That's 20. 5 times 4 is 20. 20 times 7 is 140. X squared times 4x plus 1 to the 4th. Now, eventually, we will be taking out a GCF. They both have a 4x plus 1 to the 4th would be a GCF. We could take out a 14 and an x, but we'll get to that eventually. For this first test, we're not going to worry about that. We're just going to worry about the basics. All right, and there is your answer. All right, number 9 is going to be very similar to number 6 above it, would be at sine root x. It's a trig one, but we're going to have to rewrite. Remember, 1 over x, the third, is really x to the negative third. So secant is secant tangent, right? So the derivative of the outside, the derivative of secant is secant tangent. You keep whatever's after it there. If you want to write this as x to the negative third, I probably wouldn't take off in this case, and we have that. Now times the derivative of that. Well, the derivative of 1 over x cubed is x to the negative third. Bring that, we rewrite as that, bring that out front. Take 1 away, becomes negative 4. And then we move it to the bottom, and I get times negative 3 over x to the 4th. If you leave that as an answer, great. That's perfect. All right. If you wanted to, you could move the negative 3. Could do this, negative 3 secant of 1 over x cubed, tangent of 1 over x cubed, all of that over x to the 4th. All right, either of those is fine. This is better, but I would also take that as well. All right, last 2. All right, now this one, 10 is the only one that you don't have to use the chain rule on this worksheet. All right. This is one of the ones where you split up. So you do x to the 4th over x squared, simplify that, which is x squared. You have negative 2x over x squared, which is negative 2 over x. And then you have 1 over x squared, which is 1 over x squared. And we're going to just take the derivative of each of those. All right. So the derivative of x squared is 2x, nice easy one. Negative 2 over x is negative 2x to the negative first. We then do power rule. Negative 1 times negative 2 is positive 2x to the negative second, which gives me plus 2 over x squared because we can't have a negative exponent. 1 over x squared is really x to the negative second. Power rule, that comes out front. Negative 2x to the negative third. You get minus 2 over x cubed. There is our answer. All right, last one. All right. First term, second term, we have product rule, which is the first times the derivative of the second plus the second times the derivative of the first. All right, so the first is 2x plus 1 to the 4th times the derivative of the second. Well, that's a chain rule. Bring the 5 out front. Keep the inside the same, 3x minus 7. The 5 becomes a 4 times the derivative of the inside, which is just 3, plus the second. So rewrite the second function, 3x minus 7 to the 5th, times the derivative of the first, which we do the chain rule again, which is 4. Keep the inside the same, is 2x plus 1. The exponent 4 becomes a 3 because we subtract 1. Then we multiply by the derivative of the inside. Don't forget that step, over 2. And just like that, that is the product rule. If you get that, great. You understand what's going on. Just multiply any numbers that are constants out front. 3 times 5 is 15. 2x plus 1 to the 4th. 3x minus 7 to the 5th. Plus we have 4 and a 2, which is 8 and that's 8, 3x minus 7 to the 5th, all right, times 2x plus 1 cubed. All right, so there you have it, all right? So hopefully if you had any questions, this clears it up. You can also use this to look back if you have questions on anything with the chain rule or double chain, right? This gives you a good, good recap of how you would do it. All right, thank you.